Hi, my name is Ahmad Shahid bin Muhammad Salahuddin. My metric number is AA210707 and my topic is the principle of moment. First of all, the objective of this experiment is to understanding the principle of moment. Firstly, what is principle of moment? The principle of moment states that when a body is balanced, the total clockwise moment about a point is equal to the total anti-clockwise moment about at the same point. So the application that I use in this experiment is seesaw. The question is, how does it works? Moment also have a direction, either clockwise and also clockwise. Now we look at the seesaw. When no one is sitting on the seesaw, the moment in both direction is equal. But when one person sit down on the seesaw will move, that is move downwards. If another person join them by sitting at the other end of the seesaw, so their body weight will create a moment in the opposite direction that we can calculate with a formula, moment equal to Fd, which is F is force and D is direction. That's all from me. Thank you.
Okay, so I'll be talking about the applications of principle of momentum, and the application that I'll explain about is optical tweezers. And the objective of optical tweezers is that it uses light to manipulate microscopic objects as small as a single atom. The radiation pressure from a focused laser beam is able to trap small particles. In the biological science, these instruments have been used to apply force in the PN range and to measure displacements in the NM range of objects ranging in size from 10 Newton meter to over 100 millimeter. So I'll be explaining more about the optical tweezers. The basic principle behind optical tweezers is the momentum transfer associated with bending light. Light carries momentum that is proportional to its energy and in the direction of propagation. Any change in the direction of light by reflection or refraction will result in a change of momentum of the light. If any object bends in the light, changing its momentum, conservation of momentum requires that the object must undergo an equal and opposite momentum change. This gives rise to a force acting on the object. In a typical optical tweezer setup, the incoming light comes from a laser which has a Gaussian intensity profile. Basically, the light at the center of the beam is brighter than the light at the edges. When this light interacts with the bead, the light rays are bent according to the law of reflection and refraction. The sum of the forces from all such rays can be split into two components: the scattering force, pointing in the direction of the incident light, and the gradient force, arising from the gradient of the Gaussian intensity profile and pointing in XY plane towards the center of the beam. The gradient force is a restoring force that pulls the bead into the center. If the contribution to the scattering force of the refracted rays is larger than that of the reflected rays, then a restoring force is also created along the z-axis, yielding a stable trap. The image of the bead can be projected on a quadrant photodiode to measure Newton meter scale displacements. When the bead is displaced from the center of the trap, what force does it feel? The restoring force of the optical trap works like an optical string. The force is proportional to the displacement out of the trap. In practice, the bead is constantly moving with Brownian motion, but whenever it leaves the center of the optical trap, the restoring force pulls it back to the center. If some external object like a molecular motor were to pull the bead away from the center of the trap, the restoring force will stop it. That's all from me. Thank you.
So I will talk about scissors. As we know, scissors are used to cut thin materials like paper, cloth, metal foil, rope and wire. So example of scissors that I will give you is cutting a piece of paper. So how does it work? A pair of scissors use a combined mechanism known as compound machine. Compound machines are comprised of two or more simple machines in an effort to more efficiently exert force, like the cutting of an object. The blades of the scissors are a pair of wedges in a cross shape which pivot around a fulcrum. The attached handles are levers. When force is applied to the handles, it causes the bladed wedges to come together to cut an object from both sides.
The definition of a beam balance is that it is a device that is used to determine the mass of a body under gravitation. In the figure, there are two pens suspended by a hook and separated by equal distance from the center. There is another hook in the center to support and hold the balance. The object whose mass has to be measured is placed on one of the pens. Standard weights are placed on the other pen until the metallic beam becomes horizontal and pointer becomes vertical. The sum of the total of all weight used gives the mass of the object. Phenomenon of balance is based on the moments of the two bodies at both corners. In short, we can say that when there is some same amount of total clockwise moment equals to total anti-clockwise moment, then the body is said to be in balancing position. A beam balance works on the principle of moments according to which in equilibrium, the anti-clockwise moment due to the weight of an object on the left pen of the beam is equal to the clockwise moment due to the standard weights of the right pen of the beam. The principle of moments states that when a body is balanced, the clockwise moment about a point equals to the total anti-clockwise about the same point. Total anti-clockwise moment equals to total clockwise moment.